up at the night sky. The universe is overflowing with helium. It is the second most abundant element in all of existence, after hydrogen. And yet, here on Earth, we are quietly running out of it. Because helium is so light that once it escapes into the air, it drifts up, past the clouds, past the atmosphere, and out into space, gone forever. Most people know it only as the gas in party balloons, a cheap novelty, a joke. But helium is one of the most critical and most irreplaceable resources on the planet. And the world is sleepwalking into a shortage. This is the strange, quiet crisis of a gas we cannot afford to lose. To understand it, you have to know why helium is like nothing else on Earth. It is the coldest useful substance we have, staying liquid at -269 degrees Celsius, just a whisper above absolute zero. That impossible coldness is what makes modern medicine work. Every MRI machine on Earth is cooled by liquid helium. Without it, the superconducting magnets warm up, and the machine that sees inside your body simply stops. A single scanner can hold around 2,000 liters of liquid helium. There is no substitute. Nothing else gets that cold and stays safe. But it doesn't end with hospitals. Helium cools the machines that etch the silicon chips inside your phone and computer. Rockets use it to purge and pressurize their fuel tanks. Every launch, from NASA to private spaceflight, quietly depends on it. It flows through fiber optic manufacturing, nuclear reactors, deep-sea diving tanks, and precision welding. Helium is quietly woven into medicine, technology, and space travel. And for most of these, there is no replacement at all. In a child's party balloon, it lifts a toy for an afternoon. In a hospital, that same gas keeps a life-saving machine alive. One is a treat. The other, we cannot replace. It never freezes solid under normal conditions, and it carries heat away like nothing else in existence. In the world of extreme cold, physics offers no rival. There are things we simply do not know how to do without it. No clever chemistry, no new invention has ever produced a true substitute, which makes the way we actually treat this gas almost unbelievable. So here is the problem that almost no one realizes. We cannot manufacture helium. Not in any factory, at any price. It is created deep underground, atom by atom, as radioactive elements like uranium slowly decay over billions of years. That helium seeps upward and gets trapped in pockets of natural gas. That trapped gas is the only place we can harvest it from. When we drill for natural gas, we can capture the tiny fraction of helium mixed in. Or we let it vanish into the air. And here is the cruel part. Once helium reaches the open air, it is too light for Earth's gravity to hold. It rises and escapes into space. Unlike oil or metal, it cannot be recycled or recovered. Every atom we waste is gone from the planet, permanently. For decades, one country sat on the world's greatest supply, the United States, in the plains of Amarillo, Texas. There, in a vast underground rock formation, sat the Federal Helium Reserve, the world's helium bank. Then, in the 1990s, the government decided to sell it all off, cheaply, to recover its costs. It flooded the market with artificially cheap helium, and the whole world got hooked on a price that was never real. Because it was so cheap, almost no one bothered to build new supply or to capture and recycle it. Then the reserve began to run dry, and prices lurched upward in a series of shocks the industry now calls the helium cliffs. Hospitals rationed it. Research labs shut down experiments. Scientists warned we were burning through it far too fast. In 2019, a global shortage struck so hard that party shops ran dry, and hospitals scrambled to keep their scanners cold enough to run. A small amount can now be recaptured and reused in the most advanced laboratories. But it is expensive, difficult, and nowhere near enough to matter. It was a stark lesson. A political quarrel on the far side of the world could threaten an MRI scan in your own local hospital. Scientists have even proposed pulling helium straight from the air. But in the atmosphere, it is so vanishingly thin that the idea is, for now, all but hopeless. And now, supply is dangerously concentrated in just a handful of places: the United States, Qatar, Russia, and Algeria. Qatar alone supplies a huge share of the world, and in 2017, when its neighbors blockaded it, global helium was suddenly choked. Russia raced to build an enormous new plant in its Far East, but fires, delays, and sanctions have made that supply anything but certain. A few plants in a few countries now hold the world's supply. It is a choke point hiding inside a party balloon. And yet, knowing all of this, we still release this irreplaceable gas into the sky. For fun. Every balloon that floats away carries a piece of something billions of years in the making, lost to space forever. So why should you care about a gas you rarely think about? Because it touches things you cannot live without. The scan that finds a tumor early, the chips in every device you own, the rockets that launch the satellites above your head. If helium runs short, the cost of medicine and technology climbs, and some of it becomes impossible to do at all. It is a strange kind of warning. We can run out of something the universe holds in endless supply simply because we cannot hold on to it here. We have fought over oil, over metals, over land. Helium is stranger still. The one resource that, once used, drifts beyond our reach forever. The next time you watch a balloon float up into the sky, remember what is really inside it, and how little of it we have left. If this changed how you see the ordinary things around you, there is a whole hidden world of these fights, over water, over metal, over the systems the modern world quietly runs on. Subscribe, and you'll never look at ordinary things the same way again.